Hello. Hello, can you hear me? Yes, welcome to 4th International Symposium on multidisciplinary studies and innovative technologies. Due to COVID-19, we are holding our symposium virtually. I hope this epidemic will end as soon as possible. Dear participants, is there any participants with a paper in this session? Mr. Fras Yakup. Mr. Fras Yakup, can you hear me?
Yes, I am here.
Okay. You can start your presentation if you are ready. Are you ready for presentation? Mr. Fras Yakup, are you ready for presentation? Mr. Fras Yakup, can you hear me? Mr. Fras Yakup, can you hear me? Is there any participant with a paper in this session? Mr. Fras Yakup, can you hear me?
Hello.
Hello.
Hmm. I'm from mm, the research paper number 110. Can I present?
Uh, Atiukul Islam
Uh,
Çoğutları.
actually, he's absent because of some
Okay, okay,
reason.
okay. You can start, please.
Okay, okay, thank you. Can you see my screen?
Yes.
Okay. Um, let's begin. Um, the paper actually worked the named hActNET and improved neural network based method in recognizing human activities, and I am Mohammad Sarwar Jaman, and other co-authors working with me was Atikul Islam Choudhury, Mohsen Ashraf, Ashraful Islam, Istiaq Ahmed, and Mohammad Masadur Rahman. First, actually, we have to think about what we should working with. Um, as we know, human activity recognition is one of the most challenging issues because we, when we actually think what we can do or what we are doing in our whole day, this is so much important for our prediction of our next day or our health issues is concerned, and our health issues can be measured or predict what we actually do every day about our daily routine. So we actually think about that, and that's from that point of view or from that motivation we actually were we actually decided to work on this paper. So it means to recognize the activities after analyzing a bunch of observation about any human. Nowadays, anyone can conduct various activities through smartphone. As we all know, there is many kind of sensors now are in our smartphones, such as accelerometer, gyroscope, gyroscleration. Actually, these things actually predict our motion. This sensor can predict our and measure our motion, what we are actually doing, actually we are moving or not, actually we are in a dynamic position or a static position. So these things are actually, as we mentioned here, there is some research on the activity of monitoring issue. The upgradation of this feature can help a person to monitor his or her activity to make a future decision easily. As I mentioned before, when we actually know what we are doing every day, when anyone know what he or she is doing every day, what is daily routine, then he or she can predict easily about about his or her future decision, what he should do or not, what how he can change his life, his or her lifestyle. uh, the motivation is kind of same. I actually mentioned all of the things in our introduction, but then further we can actually explain, to analyze the data of the person and their activity to get a good analysis on the data I mentioned before, to experiment previous machine learning algorithms to analyze the algorithms for recognizes process. When we actually feed or train a lot of data in our machine learning process, the algorithms and the process actually predict or actually sum up some result output, what the gist of the data actually we have to know. To develop a customized model for activity recognition, actually there is many models which can actually predict or which can actually measure the hmm, probable result or output, but we actually develop a customized model for the activity recognition, which is kind of better, more better than the existing or previous models. And previous as I can say, the previous analysis utilization of human activity recognition, which is the HAR, is quite popular in assisted living facilities consisting of Internet of Things. This is a famous thing nowadays. And then as we all know, a smartphone sensor based module for the development of human activity recognition system was built previously in previous many research and previous many projects. Actually these things are done. Some authors reviewed human activity recognition using deep learning methods from the sensors of smartphones and wearable gadgets. Actually, each and every person nowadays actually very much familiar with the smartphones, and some are also very much familiar and used to with the wearable gadgets such as smartwatch, something like that. These things can transfer learning based human action recognition methods also presented in some research. Actually, all the previous researchers actually focused on the topics or focus on the place where actually how these smartphones wearable or wearable gadgets actually how can work or how can predict our daily life. And according to this motivation or according based on this research we can actually see that those are quite good, but when it's come to the health issues or when it's come to the develop a new develop some new features for both for the smartphone companies or both for the us of the people who actually concerned about their daily lifestyle. We actually proposed or we actually try to create some new models which will we present. So very first we actually need the data set, because without the data set we cannot predict or we cannot judge the things. We cannot actually analysis what should we know, what should we actually think about. And from this point of view, human activity recognition with smartphone data set was used, where actually we actually used our full research with 30 participants, which is was kind of from 19 to 48 years. And actually here was 6 parameters, as you can see: sitting, laying, walking upstairs, walking downstairs, walking and studying. And from here you can see that here is actually some dynamic portions and some static portion, as which can mention that sitting, laying, these are the static section, and also standing in this static part. But walking downstairs or walking upstairs, the dynamic part of our data set. Now move to the next slide. Here actually the graph shows that the first graph activity analysis of each person, every person. Here we actually what deal with 30%. And here the 6 measurements, as we will see in the previous slide, there were 6 measurements. And which measurements actually or which data set or which condition actually differs or actually do with 30 different person. This first graph actually shows these data. As example, in first person we can see walking is the main priority for him. Actually most of the time he based on his every day was working. And then if we go to the 19th person, there we can see standing and lying. He's kind of a static person. He's most of the time, his or her most of the time used in standing in a position or actually laying in the position. And from a part of this, if we come to the second graph, then we can see this is a categorical graph of 6 activities, which was standing, sitting, laying, walking, walking downstairs, or walking upstairs. According to the 30 persons lifestyle, we can see here that sitting is the most time. Sitting is the part which was actually spent most of the participants do. And here we can see static activities: sitting, standing, and laying. And sitting is the most peaked part. And if we come to the dynamic part, then we can see that walking, actually most of the people every day utilize their time in walking. So here the graph actually shows the categorical graph views, actually which category was the most important or most utilized part. If we go to the next slide, then we can see the most important part of the methodology, which method we actually use. Different machine learning algorithms were applied first, but the machine learning algorithm we used for this research are logistic regression, linear support vector machine, LSVM, and random forest. Artificial neural network multi-layer perceptron was used in the next step, which was actually we used for the accuracy testing, and how much accurate actually these previous or the very first three research algorithm we mentioned, and how much accuracy we get in our proposed method that actually measured by the multi-layer perceptron. That was the first part of our methodology. Then actually After come to that, after finishing the part, after analyzing the algorithms, a customized model was applied here on HR data, which is actually a 5-layer customized neural network was designed, which was actually our proposed method for the most accuracy or for the more development method as we think actually. And in this method, actually there was one input layer, 3 hidden layers, and one in output layers in this architecture. And as we can know that to make the precise output layer, we actually need some analysis, and for this we actually use principal component analysis for extracting the important features. As here many features were introduced before, but which are the most improved, as we know, which are the most important features, they should be known for the betterment, and that's why we actually use principal component analysis for extracting the important features so we can focus on that feature. And here is the flow chart of our whole methodology. At first we start, then we start collecting our data, then we process our data actually from by dropout method. We actually remove the null values which is actually not important for our research, or which data set actually disturb our whole training system. We actually data pre-process themselves. Then feature selection, as we can see, as we can mention here, as you mentioned here, the 6 feature were selected. Then we actually use 3 traditional learning, deep learning, or we can say neural learning algorithms, and after that applied a customized neural network which has 5 neural network we mentioned before, and analyze, score all of the algorithms, which is actually the experiment result part, and ultimately we come to a conclusion. Then let's go to the next slide. Experimental result, actually what we found in our research paper, what is the main purpose and what we got in our research paper. This experiment result slide actually shows the summary of this. The 3 traditional machine learning and on deep learning algorithms have a good result but not satisfactory. As we mentioned before, all the 3 machine learning algorithms are good but not at a high peak. So actually we introduced 5-layer neural network model was created in 3 hidden layers. Actually we say I mentioned many times those three machine learning algorithms was good and quite good, but actually not at high peak. So we actually proposed a new neural network here. And we actually use 100 epochs were done in the training period. Actually we used less than 100, we used more than 100, but in 100 on kind of it's 100 or 99 or 100 or 1 was the perfect or the actually precious, and we can see the satisfactory result we can get from this 100 epochs. So after that, all the model and all the things, we actually get 96.4% accuracy, and which was more better and which are the highest among those 3. Actually actually more actually most of the among most of the experiments, or among most of the process methods, our method of that means 5-layer neural network actually accuracy level was 96.47%, and we can see in the graph here. Let's just see some random data. We actually I actually pause, or I actually stay sometimes in this slide because we want to see the difference between them. As first we can see the confusion matrix of logistic regression, and if we took a look on some part here, we actually take 561 attributes. Among 561 attributes, working performed correctly 537.0. So, and then the very next correct result was working downstairs 520. And if we to look to another method, that means linear SVM method, here we can see the working is at the highest peak among 561 attributes. There are the correct result was 537, and in this part as we can see downstairs, here we can see that some development. This is 521, and other, if we look at other parts, we can see some part is better than this method, but and some part is not so good than this method. There are two more methods. If you look at them, there random forest method and there is MLP classifier. These things are also represents the same category, but the data correction accuracy or the correct result difference we can see here. Let's have a look on this two on these two confusion matrix. After that, if we compare these previous four metrics, or these previous four methods, we can see that experiment result or model accuracy and model loss. Actually, we train 70% and we actually test 30%. And we all know that when the trend graph, trend line on the test line are closer to each other, then the model accuracy is quite good. It represents how good the model accuracy. And here we can see the train accuracy and the train line and the test line is kind of similar and kind of close to each other. That means we can say the model accuracy is quite good. And in the other hand, the model loss is opposite. When the train and test line are at the low end, and here you can see train accuracy and test line are on the peak, and here the train and test line at the bottom. So here we can also say that the model loss is quite low here. For these things, model loss is quite low. Now let's here the experimental result of our proposed method, which was the 5-layer neural network. Here we can see the walking is same, but walking upstairs, walking downstairs, and sitting, these things are improved. Actually, what the previous method used, from this previous method, all these results are actually improved. That was our main goal. Though there are slight difference, but this slight difference can make a big difference on the long run for the measuring the health issues or measuring the lifestyle of someone, how he or she can change the lifestyle. This slight difference can make a big difference in these cases. That's our main purpose, to develop a great algorithm or great method by which we can by using which model we can actually develop the whole system for both both for the smartphone companies, then who can actually develop more sensor, or for the persons, for the common people who can actually predict the life or predict themselves how he or she should do for the next times. And this is the graph of accuracy of our experiment results, and this actually shows how we improve. There we can see the logistic regression and linear SVM at the top peak 96.2%, 23% and 96.34%. But on the other hand, our proposed neural network performed 96.47%, which may seem not so different, but this change in after point can actually make a big difference, which actually I mentioned earlier, why this slight difference is actually important. And this is the actually graphical or our bar chart view of our accuracy. And here we can see actually we develop by using our model, we develop the accuracy. Okay, now move to the next slide, the conclusion part. Actually, from the whole presentation, from the beginning to end, our main goal, or I actually present to all of you, that HAR technique is used for the betterment of human beings and for the betterment of technology, which actually which actually will use for the betterment of human being. And here we also see that HAR technique is used in healthcare as an assistive technology. Smartphone manufacturing companies are trying to load their products with various type of sensors I mentioned before. This research will be good analysis in the future for detecting the activities for any person using the smartphone. These things also mentioned before. Actually, in the end, it can be said that life is our life is actually dynamic, and we have to cope up with many things. And for this reason, mobile phone companies or the technologies are upgraded day by day for the welfare or for the easy life of human being. So our research focus on that. By human human activity recognition technique, we actually help to both sides for the betterment and for the human being and for the technologies to do something new. And our research, we hope our research can help them to do this in an easy way. And here some references we used for our research. And ultimately, thank you.
Thank you very much for your presentation. Dear participants, do you have any question about this article?
Excuse me?
Okay, no question. Thank you again. I wish you success in your career. Hope to see you.
You're most welcome.
Okay. Dear Belkacem Boali, are you ready for your presentation? Mr. Belkacem Boali, can you hear me? Mr. Belkacem Boali?
Yes, Mr. Yasser, yes.
Okay.
I am here, yes.
If you are ready, please.
I share my screen.
Okay, please. Please, you have 10 minutes at most. Okay.
Okay, it's clear. I can start.
Okay. You can start your presentation.
Yes. Hello and welcome to this presentation. I am Dr. Bouali Belkacem from University of Laghouat, Algeria. The title of our presentation is Performance Analysis of Parabolic through Concentrator with a Curved Secondary Reflector. The main objective of this work is to improve the optical and thermal performance of the system. The following figure shows a PTC with a second reflector. As can be seen, the system consists of three main parts. The primary reflector, which concentrates the solar radiation coming from the sun. The second reflector, which concentrates the rays reflected from the primary reflector. And an absorber tube, which collects the heat of the radiation coming from the two reflectors. This heat is then absorbed by a heat transfer fluid circulating in the tube. The analysis model is organized into 5 steps. The first step is to obtain hourly solar flux data for the city of Laghouat, located in southern Algeria. This is done using PV system software. The second step is to find Gaussian interpolation functions for these data, which allow to have the solar flux at any time. To do this, the MATLAB CF toolbox is used. Then, salt trace code is used for the optical analysis of the system. This step will allow to obtain the distribution of heat flux on the lateral surface of the absorber tube. In the fourth step, the ANSYS CFX solver is used to solve the equations of conjugate heat transfer and fluid flow within the absorber tube. Finally, the obtained results can be processed using ANSYS, CFDPost, or TechPlot and MATLAB. Here we have represented the solar radiation data for the city of Lagwat for 4 days in different seasons. As I have mentioned, these data obtained using software, TV system, and MATLAB. The next point is the optical analysis or ray tracing. For this, we used Sol Trace code, which uses a generalized Monte Carlo method for ray tracing. The ray tracing obtained for a PTC with secondary reflector is illustrated in the opposite figure. Now we will move to CFD section. The problem is to simulate the conjugate heat transfer and the flow within the tube. For this, we have generated a multi-block mesh as shown in this figure, where the boundary conditions are also illustrated. The governing equations are continuity, momentum, and thermal energy, where ρ is the fluid density, mu is viscosity, lambda is the thermal conductivity, u is the velocity vector, P is the pressure, and H is the enthalpy. We note that the thermal energy equation is applied for both fluid and solid. Some assumptions are made and are listed here. Now, let's move on to the obtained results. We start with the distribution of the heat flux around the tube. In this figure, we have represented two cases, PTC with and without secondary reflector. As we can see, the flux obtained in the second case is higher. As I mentioned before, this flux is introduced as a boundary condition in the CFD solver. The most important output parameter of the CFD solver is the fluid temperature at the outlet of the tube. In this figure, we have represented the temperature contour on the tube at noon for a PTC with secondary reflector. As can be seen, the temperature increases gradually along the tube and reaching the maximum at the outlet. Here, the temperature is about 700 Kelvin. In the following figure, we have represented variation of the temperature at the tube outlet during the day in different seasons. We note that the obtained temperatures in case A, PTC with second
Yes, Mr. Belkacem, can you hear me? Maybe there is a problem with his internet. Let's wait for a while.
The second parameter to consider is the thermal energy absorbed by the tube. This quantity is determined by this equation, where M is the mass flow rate of the fluid, Cp is the specific heat, T out and T in are respectively the temperatures at the inlet and at the outlet of the tube. The maximum gained energy is recorded in the month of June, while the minimum absorbed energy is recorded in the month of December. For the months of March and September, the maximum energy absorbed at noon is the same. Finally, the most important result is the thermal efficiency of the system shown in the following figures. For the two cases, PTC with and without secondary reflector, this parameter is calculated by the equation shown, where I represents the density of the solar flux and A represents the surface of the reflector. The maximum efficiency obtained is recorded during the month of June, approximately 44% for case A and 27% for case B during the whole day, while the minimum value is obtained during the month of December, around 27% in case A and 50% in case B at noon. Concerning the months of March and September, the maximum efficiency is the same, 38% in case A and 23% in case B. But in different reflect the system. We end with some conclusions listed here. The important part of this work is that the system with a ratio of about 1.62 to 1.67. Thanks for your attention.
Sure. Your Thank you very much for your presentation. I wish you success. Dear participant, do you have any question about this article? Okay, no question. I wish you continued success in your career, Mr. Bankajam Boali. Hope to see you.
Thank you.
The other paper is iris detection and recognizing by image segmentation using K-means algorithm and artificial neural network. Mr. Firas Yakup, can you hear me? Mr. Firas Yakup. Is there any participant with a paper in this session? Samalia Dambaba, can you hear me? Firas Yakup, Yusuf, can you hear me? If you are ready for your presentation, you can start. Mr. Samalia Dambaba, can you hear me? If you are ready, you can start your presentation. Mr. Firas Yakup Yusuf, are you ready? Mr. Mahmut Savaş, can you hear me? A brief characterization of the steel rods for reinforcing constructed from two steel mills in Nigeria. Belongs to Samalia Dambaba. Firas Yakup Yusuf, can you hear me? Dear Mahmut Savaş, will Samalya Dambaba present your presentation? Biraz Yakup, can you hear me? Samalya Dambaba, can you hear me? Dear Mahmut Savaş, please volume on. Your microphone is passive. Activate your microphone. Mr. Mahmut Savaş, please activate your microphone. Okay. Mr. Mahmut Savaş, if you are ready, please start presentation.
Can you hear me? Can you
Yes.
see the slides?
Yes, yes.
Can you see the slide, Chairman?
Yes, we see.
Okay, thank you. I'm talking from Lefkoşa, North Cyprus. Dan Baba was going to talk from Nigeria, and you are in Ankara. Best wishes in the symposium.
Thanks a lot.
These are Dan Baba's slides.
Okay.
It's mainly text, sorry about it, but I'll try to summarize it.
Okay, please.
Um,
Please, you have 10 minutes at
Okay.
most.
okay. In Nigeria and across the world, we always heard about sudden, unexpected collapses of buildings. Usually buildings collapse in earthquakes, but if you don't follow the standards, the buildings also collapse by themselves. It was one of the problems also in Nigeria. every year there are some human casualties and also loss of property. And of course, one of the things that you have to check is the steel, reinforcing steel used in reinforcing the concrete in those buildings. What Samuela did was he obtained he used the steel produced by two steel companies, local companies, Ajakuta and Dawanau in Nigeria. And he checked the mechanical properties of it. He checked whether it follows the standards or not. That was basically the study was about. And these are the bars that he obtained from the two local companies. The steel bars are produced from steel scrap in those two companies. So chemical analysis is important to start with, and you should follow the standard, whether it is in accordance with the standard or not. So the chemical analysis was done. Then hardness testing of these bars also carried out. Impact tests also following the international standards organization standard. Impact test was also obtained. And also the impact tester, a photo is here. Tensile testing is also done following the ISO standard that we are also using it. And this is the tensile testing machine. The microstructures were, as expected, primarily a ferritic matrix inside a perlite distribution. The chemical analysis, these are in percentages. It starts with carbon, and all the elements in the samples were found as like that in the table. And the carbon contents of the investigated steel bars from the collapsed buildings also checked. And the two undesirable impurities, phosphorus and sulfur, were also checked, noticed. And it was found that carbon contents were above the contents mentioned in the standards. These are the Brinell hardness numbers. It appears that the steel bars from Dawanau steel mill is harder than the Ajakuta one. And here is the comparison. You see Dawanau is harder than the Ajakuta samples. And when we check the impact test results, the Dawanau values are also above the Ajakuta values. That is what he has noticed. These are the tensile strength values. You note that we have 3 samples, 10 millimeter steel bars, 12 millimeter steel bars, and 16 millimeter steel bars. And they were rolled at different temperatures. You may see that the rolling temperature actually influences the tensile strength to some extent. And around 500 and 600 degrees, if you roll the samples, the steel bars on these temperatures, then the tensile strength appears to be higher than the other rolling temperatures. This is the comparison of the temperatures, effect of rolling temperature on the tensile strengths. You notice that 500 to 600 range result in higher tensile strength. We mentioned the microstructural details. It's not very clean here, but the white phase is the ferritic matrix, and the darker phase spreaded in it is the pearlite of the steel. Again, we have another microstructural details of Davanau steels and hActNET steels. The microstructural details, it is difficult to find if there is any difference between them. As a conclusion, we compared the hActNET and Davanau steel bars to use reinforcing bars for concrete. We find that some values are above the values that is listed in the standard. However, some values are below the values reported in the standards. So a further study is necessary. Compression tests and fatigue tests, for instance, should be done. And also the steel bars from the collapsed building should also be investigated. Since I'm not the primary speaker, sorry about the short talk, the undetailed talk, and all the best. Thank you.
Thanks for your presentation. Dear participant, do you have any question about this article? Okay. I wish you continued success in your career, Mr. Mahmoud Savaş.
Best wishes, the chairman.
Thank you.
Thank you, and best wishes.
Mr. Firas Yakup Yusuf, are you ready for your presentation? Can you hear me? Mr. Firas Yakup? Mr. Firas Yakup? If you will not present your presentation, I must finish this session. Is there any participant with a paper in this session? Dear participants, thank you for attending this session. Have a good day. Hope to see you.